Hi, today we're going to be learning about equivalent ratio tables as well as equivalent number lines. In front of us we have a table, and a table is different than a number line in that it does not have to go in order from least to greatest when you read these from left to right. However, you solve for the missing values the exact same way. So let's pretend that we're comparing daisies to tulips, and the ratio would be for every 2 daisies we will also have 5 tulips. So that's why those are located in the first 2 boxes. That has our initial ratio. In order to solve for what's in this first empty box, we're going to look at the numerators because we have a starting point, which is 2, and we have an ending point, which is 12. We're always using multiplication for these tables or number lines, and so we have to ask ourselves, how many times does 2 go into 12? Hopefully you're thinking 6. And if this whole concept of equivalent ratios means to multiply and to what you do to one side you have to do to the other, it only makes sense to take the 5 and multiply it by 6 as well. 5 times 6 is 30. And so for every 12 daisies, we would have 30 tulips. Let's try that same concept, but now with different numbers. It looks like in order to figure out how many daisies we have for that second box, we have to now analyze the denominators. Our tulips started at 5, but now we're ending at 10. So we're thinking how many groups of 5 are within 10? That's right, 2 groups. So I'm going to label that rainbow as multiplying by 2 so that it reminds me when I start with the daisies and go to that same area, I have to take the daisy number and multiply it by the same factor. So 2 times 2 is 4, and that's our second answer. The last box, so our longest rainbow, looks like we have to start with the numerators. If it starts at 2 and ends at 52, I know it's going to be a relatively large number, so you might have to use division to figure out that missing factor, guess and check, use a calculator, but just somehow figure out how many groups of 2 are in 56. Hopefully, you come up with the number 26. What you do to one side, you must do to the other. So we're going to take 5 and multiply it by 26. You can use a calculator or whichever method it takes to solve it, but you should eventually get 130 tulips. So it's the same exact ratio. For every 52 daisies, there are 130 tulips. If you were to use your scaled down method, you would still have that simplify all the way down to 2 over 5, which is what our initial ratio was. They're just higher numbers. Let's now take a look at an equivalent number line. And the main difference between this and the table is that you have to go in order from least to greatest. So I can tell that for every 3 of something, there's going to be 7 of something else. That's the initial rate or ratio. I'm going to start with the second dot, which is my first missing spot, and treat it like it's an equivalent table, which means it looks like I'll be starting at the top because I have a starting and ending spot from 3 to 9. I know that there's 3 groups of 3 within 9, so what you do to one side, you do to the other. 7 times 3 is 21. All right, let's now try the next group of numbers. And I believe we're going to have to start the numerators again. And you could try using this number, but I don't think 9 goes into 30 evenly, so unfortunately that's not going to work. And I'll go back to our initial rate using the 3. How many groups of 3 are in 30? Hopefully you're thinking 10, which means this number is going to be 7 times 10, which gets us to 70. We have one more, and because we have the unknown at the top, I'm going to have to first start with the bottom numbers. So how many times can 7 go into 98? I believe it'd be 14, so I'm going to just quickly try this out. And yes, it's going to be 14 times. So now I have to figure out what is 14 times 3. If you said it's 42, you were exactly correct. The only difference, to restate what we thought about at the beginning, is that number lines go in order from least to greatest, whereas going back to our table, they can go in any order. They could start as scaling up, then they can go back to scaling down, and then back up again. There's no rhyme or reason as long as they're equivalent, which means you're multiplying by the same factor. So I hope this video helps, and have a wonderful day.